Okay, number 47 says use the limit process to find the area of the region between the graph of the function and the x-axis over the given interval and sketch the region. Okay, now I'm going to leave the sketching the region to you just because I doubt I can even finish the whole problem, working the algebra on it. But you could draw a picture of that graph and just bound it with x is 0 and x is 1. If you look at this, here's what we're going to do. We're going to use, first of all, if we're going to use the limit process, we have to think about those rectangles that we're drawing. We don't know how many rectangles. They don't tell us how many here, so we're going to just assume that we're going to let there be n rectangles. And since they say use the limit process, at the very end, we'll take the limit as n approaches infinity to find out, what the area would be. All right, so since I don't know, since I'm going to say there's n rectangles, my change in x here is going to be 1 minus 0. Remember, I just take the two endpoints and subtract them, and then I'm divide them by n into n equal parts. So that would be 1 over n. So now if I go to find that summation, remember what I'm going to do is I'm going to take the limit as n approaches infinity of s of n. Okay, so let me just do s of n first. We'll do the limit at the end. That way maybe it'll make it less writing on the screen and we can keep up with it better. So the sum from I equal 1 to infinity, or 1 to n, we're going to, at the end, we'll put infinity. It's supposed to be an equal there. What we want is remember, we're taking areas of rectangles, so we want our base, or, our length, times our height, okay? So base times height. Now this 1 over n, that's going to be our base of each rectangle. They usually write it second when you see books write it. And then what I want is f of this 1 over n as I equal 1 to n, okay? So basically, whatever I divided it into, I'm going to have to take, it didn't matter, remember the book talked about it didn't matter whether it was the lower sum or the upper sum, the limits are the same. So we'll just do, we'll just put f of 1 over n, and we won't worry about whether that's the lower or the upper limit, okay? Now, so it's sum of I equal 1 to n. We want to take the limit of that at the end. And the function is negative 2. Remember, we're going to plug in all those I over n's and add 3. But then it gets multiplied by 1 over n, okay? So now what I did was this. I did mine and I checked it with the answer key, and I put more steps in, but that's okay. I'm sure they're just skipping some, but we come up with the same answer. It's the sum I equal 1 to n of, okay, so what I did next was I basically distributed this 1 over n to each term. I just kind of, for me, that works out easier. Let me write the first term in blue. When I do that, I get negative 2 times I, and then you got your 1s, which is negative 2i on top. And then I've got the n times the n, which would be n squared. And then plus 3 over n. Okay. Now, then what I did is I said, okay, let's pull out what we can. I'm going to split that into 2. First of all, let me split it into 2. There's 1 to n of negative 2i over n squared plus the sum of I equal 1 to n of 3 over n. Okay. So then I did each of those sums separately. It just helps me to write it that way and keep it separate. I need small steps. I could take out a negative 2 and an n squared out front. Didn't really leave myself a lot of room for that. You know what? Let me just write it down below, and I'll go on to a new screen. I took out a negative 2 and an n squared, and then that left me with the sum of I equal 1 to n, and I just had I. Now that's going to be real easy in a minute for me to go use those rules that we talked about that were earlier in this chapter. Then I'm going to say that's 3 over n, sum of I equal 1 to n, and there would be a 1 left. Okay, so now that would be negative 2 over n squared, And now the sum of I equal 1 to n of I, getting that formula out of, that little box that they gave us in the book. Formula for the sum of 1 to n of I would be this. Plus, remember, I had pulled this out. And the sum of I equal 1 to n of 1 would just be 1 times n, which would be n. Okay, so if we simplify this, the 2's cancel out. I've got an n here that cancels out with an n here. That leaves me an n on the bottom. So what I end up with, I'll write in a different color so you can see the next step. That would be negative n plus 1 over n. And then these n's would cancel out and I'd have 3. So let me break those terms up. That's negative n over n minus 1 over n. Don't forget to distribute the negative sign, plus 3. That's when this is my s of n. I just simplified it. Now I'm going to take the limit as n approaches infinity of s of n. So that's the limit as n approaches infinity. Ooh, negative n over n is negative 1, and then I have minus 1n over n plus 3. All that. Well, that would just be negative 1, and then minus 1 over n. If I plugged infinity in, that would go to 0. So I have negative 1 plus 0, and then plus 3. Negative 1 plus 3 is 2. There you go.